Real-time rendering is one of the interactive areas of computer graphics. It means creating synthetic images fast enough on the computer so that the viewer can interact with a virtual environment. The most common place to find real-time rendering is in video games. The rate at which images are displayed is measured in frames per second, frame per second, or hertz, Hz. The frame rate is the measurement of how quickly an imaging device produces unique consecutive images. The graphics rendering pipeline. Graphics rendering pipeline is known as the rendering pipeline or simply the pipeline. It is the foundation of real-time graphics. Its main function is to generate or render a two-dimensional image, given a virtual camera, three-dimensional objects, an object that has width, length, and depth, light sources, lighting models, textures, and more. Architecture. The architecture of the real-time rendering pipeline can be divided into three conceptual stages as shown as in the figure below. These stages include application, geometry, and rasterizer. This structure is the core which is used in real-time computer graphics applications. Application stage. The application stage is driven by the application where it begins the image generation process that results in the final scene of frame of animation, therefore creating a base filled with simple images that then later on build up into a bigger, more clear image. The application is implemented in the software, thus giving the developers total control over the implementation in order to change the performance. This stage may, for example, contain collision detection, speed-up techniques, animations, force feedback, etc. One of the processes that is usually implemented in this stage is collision detection. Collision detection usually includes algorithms that detects whether two objects collide. After a collision is detected between two objects, a response may be generated and sent back to the colliding objects as well as to a force feedback device. Other processes implemented in this stage included texture animation, animations via transforms, geometry morphing, or any kind of calculations that are not performed in any other stages. At the end of the application stage, which is also the most important part of this stage, the geometry to be rendered is fed to the next stage in the rendering pipeline. These are the rendering primitives that might eventually end up on the output device, such as points, lines, and triangles, etc. Geometry stage. The geometry stage is responsible for the majority of the per-polygon operations. A per-vertex operation. It means that this stage computes what is to be drawn, how it should be drawn, and where it should be drawn. In some case, this stage might be defined as one pipeline stage or several different stages, mainly due to the different implementation of this stage. However, in this case, this stage is further divided into different functional group equals model and view transform equals. Before the final model is shown on the output device, the model is transformed into several different spaces or coordinate systems. That is, when an object is being moved or manipulated, the object's vertices are what are being transformed. Equals lighting equals. In order to give the model a more realistic appearance, one or more light sources are usually equipped during the scene of transforming the model. However, this stage cannot be reached without completing the 3D scene being transformed into the view space. The view space is where the camera is placed at the origin and aimed in a way that the camera is looking in the direction of the negative z-axis, with the y-axis pointing upwards and the x-axis pointing to the right. Equals projection equals. There are two types of projection: orthographic, also called parallel, and perspective projection. Orthographic projection is used to represent a 3D model in a two-dimensional 2D space. The main characteristic of orthographic projection is that the parallel lines remain parallel even after the transformation without distorting them. Perspective projection is when a camera is farther away from the model. The smaller the model it appears. Essentially, perspective projection is the way that we see things from our eyes. Clipping Clipping is the process of removing primitives that are outside of the view box in order to continue onto the rasterizer stage. Primitives that are outside of the view box are removed or clipped away. Once the primitives that are outside of the view box are removed, the primitives that are still inside of the view box will be drawn into new triangles to be proceeded to the next stage. Screen mapping The purpose of screen mapping, as the name implies, is to find out the coordinates of the primitives that were determined to be on the inside of the view box in the clipping stage. Rasterizer stage. Once all of the necessary steps are completed from the two previous stages, all the elements, including the lines that have been drawn and the models that have been transformed, are ready to enter the rasterizer stages. Rasterizer stage means turning all of those elements into pixels, or picture elements, and adding color onto them. Moller, Thomas, Haynes, Eric. 1999. Real-time rendering. First ed. Natick. M.A. A.K. Peters. Limited. Salvatore. Dave. 21 June 2001. 3D Pipeline. ExtremeTech.com. ExtremeTech. Retrieved 2 February 2007. Malhotra. Priya. July 2002. Issues involved in real-time rendering of virtual environments. Masters. Blacksburg. VA. College of Architecture and Urban Studies. pp. 20-31. Retrieved 31 January 2007. Haynes, Eric. 1 February 2007. Real-time rendering resources. Retrieved 12 February 2007.